How's it going, fine people? Happy Monday. We're going to try something a little different today. I'm bringing you a video lesson that is just a screenshot. It's not going to be any faces, not going to be any other people. It's just going to be me. This lesson is brought to you by Distance Learning, now good through the end of the school year. I'm not sure if you heard, but we are good through the end of the year here, people. So keep on getting that work done. Keep on working hard. If you have questions, as always, please make sure that you come to the online office hours or send me a note. You guys have been doing a great job with keeping up with work, and please remember that if it's late, I will still give you credit for it, okay? So you got your guided notes up. Today we're working on arithmetic sequences. For arithmetic sequences, it's a fancy way of saying we're using a pattern of addition or subtraction, okay? Addition or subtraction. Just keep that in mind. So here we are looking at this first sequence. We've got 21, 16, 11, 6, 1, and -4. The value of the first term is, yeah, I actually want you to answer the question before I just reveal it to you. That's right. Okay, so the value of the first term is 21. No trick there. What's the pattern, or what's the rule here? Yes, that is true. It is -5 each time. I say it's decreasing by 5. So I got -5 each time. So then you guess the next two terms in the sequence. If you do -4 minus 5, you're going to get -9. -9 minus 5, you get -14. So there it is right there. Okay. So that's what we're doing here. We got addition and subtraction sequences or patterns. Okay. Here's the next one. Value of the first term here, -3, yep. How is this changing from one term to the next? Yeah, we've got adding 8 each time, or +8 each time, okay? Next up here, if I asked you the 9th term in the sequence, okay, so what you'd have to do is, this is 1, 2, 3, 4, 5th, 6th term, you have to add 3 more terms, add 8 3 more times, I should say, to get to the 9th term of the sequence. You can either just do it the long way, add 8, add 8, add 8, or you could say, oh, I got to do 3 times 8s. So, or sorry, 3 8s, so that's 8 times 3, excuse me. So I'm going to add 24. Either way, you're going to get 61, okay? All right, next one. If I'm looking at this sequence here, not a trick question. What does the ... mean at the end here? It means that this sequence will go on forever. That is correct. And the numbers are the actual terms in the sequence, okay? All right, so arithmetic sequences, they are like showing a difference, like a common difference between each of the terms, okay? And it's always consistent or the same. Sometimes we call it a difference. Common difference is very typically used here. And you can equate these with linear equations, okay? Because we've got a constant rate of change. That's the same thing as saying a common difference that is constant over time here. So linear equations are often equated to arithmetic sequences, which is why you can write them that way, all right? You've got, this is what it would look like in a table. There are some blanks in the table that you can also fill out. But as I did in the other one, right, you can either keep adding the difference until you get to the term that you want, or you could actually create a rule that would you could just plug in the term number that you want and you could find your answer, okay? So that's what we're going to talk about here. We got 2 different ways to do it, okay? We can write rules either using our explicit rules or our recursive rules, okay? The things that we need to make that happen are the first term, and we need to know what the actual rule is, or the common difference, okay? So in this one, here's our sequence. first term is, yep, 3. And the common difference here, I would go from 3 to 8, 8 to 13. So the common difference is plus 5 each time, okay? So if I'm doing an explicit rule over here, I can do the same sequence, and I can either write it as an explicit rule, which means I can just plug in whatever number that I'm on and I get directly an answer. The way I would do that is I would say, okay, I take my first or my starting term and I add to it the common difference, okay, from the previous term. Remember that I said n minus 1 means like the previous term. I said that in the last lesson. So here, if my first term is 3 and my common difference is 5, I'm going to put those two in and I end up with this, okay? I've got my first term, I've got my common difference of the previous term, or n minus 1 here. That's how you write an explicit rule. That way, whatever n is, let's say I want the 9th term, I just plug in 9 here. If I want the 42nd term, I plug in 41 here, and I just solve it. It's that simple. Explicit rules are the easiest, the fastest way to get the answer that you need, okay? Recursive rules work a little differently. Recursive rules require that you have to use, like you have to have the first term given to you, okay? So I would have to actually write f of 1 is equal to my first term, which is 3. And then what I would say is f of any number, n, is going to be the f of n minus 1 plus my common difference, okay? So I would say my f of 1 is 3, and then the recursive rule is f of n minus 1 plus 5. I'm taking my previous term and I'm adding 5 to it. That's recursive rules, okay? So again, the recursive rule in the sequence, sometimes we write it as like any, we can say f of n, or we could say a sub n is 3 plus 5 to the, or times n minus 1. Same thing here. Instead of saying f of 1, we'd say a sub 1 is equal to 3. And a of any number would be a sub n is equal to a of the previous term plus 5, okay? Recursive rules require that you know the previous term, or n minus 1, whereas explicit rules, you can just plug in your number, whatever number it is, and just jump straight to the answer. My preference is explicit rules. That's what we mostly do here, okay? We're gonna do one more example, and then I'm gonna let you guys go. Obviously, the guided notes are all available online. All right, so task number 1, first term in the sequence. Yep, you got it, 10. And the common difference here, I already have it kind of written there, is minus 6, okay? So if I'm writing a recursive rule, I'm going to say f of 1 is equal to my first term, which is 10. And then I'd say f of n minus 1, and then my common difference here is minus 6, okay? If I'm doing an explicit rule, I start with my I start with my first term, which is 10. And I'm going to say 10 plus my common difference times n minus 1. My common difference is 6, so I'm actually going to do 10 minus 6 times n minus 1. Okay, so again, if I'm going to put in any number, right? If I want the number 42, I want the 42nd term in the sequence, I'm just going to plug in this 42 right where that n is, right? And I would say, just like that, 10 minus 6, and instead of n minus 1, I'm going to say 42 minus 1. And then it's just a straight up PEMDAS. How do I solve this? 42 minus 1 first, then I do my parentheses, then I can do subtraction, and I end up with the 42nd term in my sequence is negative 236, okay? Again, arithmetic sequences, you can either do them as recursive or explicit rules. Either way, it's either involving addition or subtraction. We call it the common difference. That's going to be your rule. All right, next up is going to be geometric sequences, which involve multiplication. Keep getting that work done. Keep working hard, guys.